Hello and welcome to today's lesson. Today we're going to look at the equation of a circle. Now to start us off, I've drawn a nice little simple circle, nice little graph here, and we're going to try and develop where and what the equation of a circle might look like. Well, a couple of things about this little circle. Very important to notice that it has a center at 0, 0, the origin. And it has, the other important thing about a circle is what's its radius. Radius of this circle is 2. So start off with a very simple circle. Now what I'm going to do is I'm going to take any point that's on the circle. And to represent any point, or the general point, I'm just going to take some x and some y. Okay? So I'm just picking x and y to represent some point that's on the circle. Now, what is it that we know about every point that's on the circle? Well, the distance from this point to the center of the circle, okay, that distance is 2. It's the radius of the circle. So now that gives me some indication as to what I can mathematically build up. Distance between this point and the center of the circle can be expressed using the distance formula. So it would look like this. Okay, the distance between this point and this point, well, that's x minus 0 all squared plus y minus 0 all squared. And the distance has to equal the radius, which is 2. All of a sudden, I have a mathematical representation of what we're saying when we say this particular circle. Now I'm going to clean that up. To start with, I'm going to square both sides to get rid of the square root symbol on the left. And at the same time, I can see x minus 0 is just x. So this is just going to be x squared. This is just going to be y squared, and if I square both sides, 2 squared is 4. And there it is. This is the equation of this circle. Now that's basically a nice, simple way to look at it. You've got x squared plus a y squared equals, now think of this guy here as your radius squared. Okay? So that's what you have happening. X squared plus y squared equals radius squared. Not bad. Now I'm going to up the ante a little bit by throwing in some shifts, some transformations, and show you what that looks like with this next example. So now I'm going to throw at you, well, what if we have to graph something like this? X minus 1 squared plus y plus 3 squared equals 1. Okay, so we've upped the ante a little bit here. Well, all that's really different from the previous circle is they've tucked in some numbers with the x and with the y. And what that means is you've got some shifting going on. Now, that shifting can be a little bit confusing. Here's a little trick to keep it clear. Just go on the x-axis to whatever number turns this to 0. That means that we're going to go to positive 1. Because positive 1 minus 1 turns this to 0. So that means on the x-axis we want to go over to 1. And what I usually do is I draw a little dotted line to kind of visually guide me as to where this shift has actually occurred. So I do a little guideline like that. On the y-axis, we want to go to negative 3. Again, thinking what turns that to 0. So we want to go down to negative 3. And again, I draw a little guideline. Now, if you ignore the shifts, what we're really talking about, this is a circle with a radius of 1. Because remember, this is your radius squared, and 1 squared is still 1. So if you look at it, this circle would be the same circle congruent to this one, but without the shift. So what I'm now going to do is think, well, I know where the center is. The center of this circle has been moved 1 to the right and down 3. And this circle has a radius of 1. So I treat this as the center of the circle, which it is. And from there, I just think, well, radius of 1. So go 1 to the left, 1 to the right, up 1, and down 1. And that helps guide you to drawing a nice, neat little circle. There it is. Okay, there's the graph of this circle's equation. So let me just generalize so you know exactly what this formula for circles looks like. Just write it out for you. Every circle can be written in this form. X minus h squared plus y minus k squared equals r squared. And what we have here is the center of the circle would therefore be at h, and on the y-axis at k, and it has a radius of r. So there's your standard form, your guideline for every circle. It makes it really easy to draw the picture of any circle if you think of this. Okay, well, I have one last example. And in this last example, what I'm going to do is try and find the equation. So we're going to be giving you some information. I'm going to tell you the center of the circle is at -3, 4. And we're going to not tell you anything else except that there's one point on this circle that we know. So it passes through the following point, 1, 2. Okay. And that's all we tell you. You're supposed to be able to find the equation of this circle. Well, most of it is given away right off the bat. Let's start off with our standard form here, our template, which is this. Okay, so I look at that and I go, hey, there's only this thing, the h, this thing, the k, and the r squared that I don't know. 3 things. 2 of those things are just a matter of reading it off from the center. If you've shifted your center 3 to the left, or to -3, that means in here you want to see x plus 3, so that -3 and 3 makes 0. Okay. In a similar way, if I want to put 4 in here for y and see this thing turn to 0, then I want to see y minus 4 squared. Okay. Well, that's 2 of my unknowns. The only thing I don't know is this r squared thing on the right. How do I get that? Well, we're going to use this information that this is a point on the circle, which means if I put in 1 for x and 2 for y, it's got to make the equation true. Otherwise, it wouldn't be a point on the circle. And that's how we're going to get this r squared bit. So I'm going to put 1 in for x. I'm going to put in 2 for the y. And solve. So this is going to be 4. And 4 squared is 16. This is going to be -2. And -2 squared is 4. So now I know that r squared is 20. So what could I do to finish this up? Well, I can go back to save rewriting the whole thing since I have the magic of the chalkboard. I'm just going to go back up here and replace r squared with r squared is equal to 20. So I'm going to put the 20 in there. And there it is. There's the equation of this circle with this center passing through the point 1, 2. Now just one word of caution. Keep in mind that this is not the radius of the circle. This is the radius squared. So if you're asked to identify the radius of the circle, well, the radius of this circle, okay, we'd have to do a little work here. Okay? We know that the radius squared equals 20, so I would have to square root both sides, And so I'd be looking at the square root of 20. That's the actual radius of the circle, which is approximately 4.5. Okay, so be very careful. If you're asked to draw a picture of this now, if you incorrectly identify the radius, you're going to have a pretty strange looking drawing. As it stands, it shouldn't be too bad. We want to shift over to -3. We want to shift on the y up to +4. So there's our center. And all we have to do now is put in a radius of about 4.5. Now you might say, whoa, how can I draw that? Well, it's just a drawing. So it just means that from your center you want to go 1, 2, 3, 4, and a little bit, 4.5, so about that far. We want to go down 1, 2, 3, 4, and a little bit. Up 1, 2, 3, 4, and a little bit. And to the left, 1, 2, 3, 4, and a half. So there you go. All you got to do is draw your circle now through these points. And you get a pretty reasonable drawing. Okay? Well, that concludes my talk on the equations of circles. And so with that, we'll catch you later.